Dissolving and the forces of attraction. Dissolving is a physical change, okay? So the molecules or ions of a solid solute are held together by bonds, and when dissolving occurs, these bonds break, and the ions or molecules of the solute become attracted to the solvent particles. So, for example, there's a depiction of salt, okay, being dissolved by water molecules, and as you can see there, they're taking the ions, they're taking the chlorine and the sodium ions, and they're pulling them out of the salt crystal, and they're surrounding them, allowing them to be dissolved in our solvent, our solute. Okay, so the three processes that are involved in dissolving are: 1. Bonds are broken between molecules or ions of the solute, and it's always an endothermic reaction, so it requires energy. Then bonds are broken between molecules of the solvent, which is always an endothermic reaction. And then finally, bonds form between molecules or ions of the solute and solvent, which is always exothermic. So we have two endothermic reactions, so the breaking of the bonds between the molecules or ions of our solute, and then the bonds being broken between the molecules of the solvent. Overall, though, the energy change in dissolving is equal to the sum of these three steps. It is the law of conservation of energy. So if more energy is released than is required, the overall dissolving process is exothermic, so it gives off heat, or it gives off energy. And if less energy is released than is required, the overall dissolving process is endothermic, or it cools. Okay, we have that sensation of cooling. So electrolytes versus non-electrolytes. Electrolytes, weak and strong, are aqueous solutions that conduct electricity. For example, all soluble ionic compounds, very polar molecule compounds like acids and ammonia, okay? Where non-electrolytes are aqueous solutions that do not conduct electricity. For example, we have molecular compounds in a solution. So dissociation occurs when ionic compounds break into their ions when they are dissolved in an aqueous solution. Dissociation equations are used to show what happens to a substance when it is put into water. So you have 4 situations. You have insoluble ionic or molecular compounds. These do not dissolve to any great extent, and they use the solubility table for ionic compounds. For example, AgCl, okay, it's a solid, okay, it doesn't break apart, it's still there. But when we have C25H52, okay, this is also going to be a solid. These are things that do not dissolve. These are things, if we look at our solubility table for ionic compounds, they have low solubility, okay? 2, we have soluble ionic compounds. These dissolve to a great extent and form ions in solution. The ionic bonds are broken, and we use the solubility table again. These include bases, which turn the litmus paper blue, and we need to balance the number of ions. So for example, we have salt, okay, which turns into our sodium ion and our chloride ion, okay? And then we also have this situation here where we get the same sort of breaking apart of ions. And again, we need to balance these, as we see here, with the with our 2OH, okay? We're going to talk about the next different types of compounds in the next video.